To finish off our quadratic unit, we're going to go back and remind ourselves about taking the inverse of a quadratic. So from our last unit, when we took the inverse of a quadratic, there's our original y equals x squared, our original graph. And when we took the inverse of it, it looked like this. And when we did that, we realized that it was the inverse was not a function because it didn't pass the straight line test. For every input, it had two output values, and that is what the definition of a function is, that there's only allowed one output for every input. So, if we talk about our parabola as y equals x squared, and let's say I only graphed half of it. So for y equals x squared, our parabola, our quadratic, if I only put positive numbers into x, 0, 1, 2, 3, I would only end up with this half of parabola there. So when I took the inverse of this parabola, I would have that there. And that is a function because for every input, there's only one output. For every x value into the equation, there's only one y value. So now, our inverse is a function. This works also for the negative values. If I was only to put negative values into y equals x squared, that would be my parabola there. I would only have half of it, and then therefore my inverse function would be down there, testing positive for a function because the straight line test would only touch the graph once in every spot. So therefore, if we only graph half of the parabola, it will be a function when you take the inverse of it. In order to guarantee that f at -1, the inverse will be a function, it is sometimes necessary to restrict the domain of the original function. So let's look at an example where this can be seen rather than just the words there and what it's saying. So if I had this graph here, y equals 2x minus 3 squared plus 5, I know my vertex happens at 3 and 5 and opens up. So it looks like this. So if I was to take the inverse of that parabola, it would not be a function. But what if I did some restrictions to my domain here? What if I said that x can be any real number, but x has to be greater than or equal to 3? So if I did some restrictions to my domain, I would end up with just the positive of the parabola. See, my vertex there is still 3 and 5, but I'm not using any of the values less than 3. So my parabola would look like this. Therefore, when I take the inverse of it, it would look like that as a rough sketch, not the exact values, and it would test as a function. So depending on what we want to do with our graph, we can state restrictions on the original equation so that the inverse function is a function. So all of this is great and is hopefully making sense that you can see it graphically, but we have to keep in mind that it is usually easier, faster, and more accurate to do it algebraically. So in order to do it algebraically, remember that f at x is actually just a y. And when we're looking for the inverse, it means switching the x and y values. So I'm not going to worry yet that it says x has to be less than 3. That will make sense in a little bit. So I have 2y minus 3 squared plus 8. Probably not a bad idea as I was saying that, to get yourself a sketch of what that looks like. So at 3 and 8 and opens up. So there's my parabola there of my original equation. So what it's saying is that x has to be less than 3. So if my x has to be less than 3, that means that we technically would not be graphing anything over here because all of those x's are greater than 3. So we'll continue with our work algebraically. So now we're going to have x minus 8 all over 2. We did a few steps together there. Got to be able to combine some now. And now I square root this side. 1/2 minus 4. I'm going to clean that up. because the 8 divided by 2 plus 3 equals y, or stating that the inverse function there. What we have to keep in mind though, here this is the plus and minus of that, because when you square something, doesn't matter if it's positive or negative, it will still get you the same solution. So that can be positive or negative. Now we need to go back to our domain restrictions here, and it says that x is going to be less than 3. So that means we want the bottom of the graph, the bottom half of the inverse graph, which means we want the negative value. So our final answer there is going to be x over 2 minus 4 plus 3 inverse function. So if we were to graph that exactly, we would only have half a parabola, and it would be the left side of the original equation or the bottom half of the inverse equation. Let's do one final example here, and then we're done for today. So if we had a function negative 2 x plus 1 squared minus 3, and we want to state that x is going to be greater than or equal to 1, we now know that we want the right side of the original graph, which will also give us the top part of the inverse graph. So algebraically, this is a y. Always good to give yourself that visual to start. So here, if I know all of my values are going to be greater than or equal to negative 1, excuse me, we forgot that, because keep in mind our vertex here is at negative 1 and negative 3. So my vertex is down here and it opens down. So if I'm saying that I can only have the x values greater than negative 1, I don't have the whole parabola anymore. I only have that right side. So when we switch it, x equals negative 2, 1 plus y squared minus 3. And we can do some quick algebra. Let's try and do a few steps together here. Then we do the square root of x plus 3 minus 2 minus 1 equals the inverse there. Remembering that we technically have a plus and a minus out front, but if we only want the right side, we can't have both because it would not give us a function when we inverse it. We get rid of the negative so that we just have the top part, which gives us the right side in the right side of the original equation, the top side of the inverse.